Jeff Wilkerson, professor of physics at Luther College, bringing you the next in our series of what to look for in the night sky. This time we're talking about the week of July 4th, 2022. Last week, I'm sure you've been watching that video again and again and again. We started with let's just take a moment to notice how remarkable it is. I have the same drawing on my board from last week. Somehow it managed to survive. You see, I wrote some stuff around it and erased that stuff. But I thought, I want to return to Aquila next week, so I'm going to try to keep this board intact and see if we can just use the same board, the board that was illegible last week and can be there so you can't see what it is again this week. So we started with the summer triangle. We said last week, well, I'm watching the summer triangle rise into the sky as it gets dark each evening. There it is, hanging over the eastern horizon with Altair, the lowest member of the summer triangle, right down against the horizon for me. Altair is the brightest star in Aquila, and we walked through some of these stars last week. We talked about the brightnesses of these stars and looked at a few variable stars. We said, here are a few examples of different kinds of variable stars you might go out and look at, and you might start an observing project. I'm sure you're well into that observing project and enjoying it immensely. So we won't return to that this week. But we'll look at a couple of other things from Aquila while we're thinking about this region of the sky. We talked about the bright pattern right here, looking like a diamond or a kite shape for me, with the long tail out this direction. And there are a few objects you might look for. Let's start by let's actually start with one of the brighter ones. Epsilon is a pretty bright star up here, lying less than 2 degrees, less than a couple of finger widths away from Zeta. Gamma was like that with Altair. So we had Gamma here with Altair and lying fairly close, and Epsilon formed a similar pair with Zeta. Remember, this orientation is the way it looks to me right now as it's coming over the horizon, just as it's getting dark. As the summer moves on, or as the night moves on, and this gets more to the south instead of to the east, this is going to stand up more. So this whole thing will rotate this direction. So this will look like it's more to the right of instead of above Zeta, and Gamma will look more to the right of instead of above Beta, the way that I have it drawn here. Right now, I'm sorry, not Beta, Altair. Beta's below there. But anyway, the way I have it drawn right here. So anyway, we're going to keep that in mind. But Epsilon and Zeta together form a group called Deneb al Okab. Now, Deneb, we've talked about this many times in these videos. Deneb is the Arabic word for tail. And so Deneb, in the summer triangle, the very bright star that we just called Deneb, is tail of the swan in Cygnus the swan. We've talked many, many times in the last year about Deneb al-Gadi, the tail of the goat in Capricornus, because Saturn has been sitting right next to it for a very long time and still is. So as the evening wears on, as it gets to be toward midnight or a little past midnight, you can go out and you can see Saturn right next to Deneb al-Gadi. But this is Deneb al Okab. Epsilon itself is Deneb al Okab Borealis, the northern of the tail of the goat right here. So go out, see if you can find Epsilon. Zeta, the Deneb al Okab Australis, is about 3rd magnitude. Epsilon is closer to 4th magnitude, so a relatively faint star. Starting to get hard to see for those of us who live as far north as I do. When you have to look down south to see it, it's starting to get a little bit far to the south to see. And so give it a shot. It is an optical triple. There are a couple of wide companions. A very nice, beautiful orange star. But take your telescope out and see if you can find a couple of faint companions. They're widely separated, so they're not the most dramatic of multiple star systems to see, because you don't see them right on top of each other, but you see one star with a couple of other stars nearby. And the one star, the bright star, Epsilon, is a nice orange star. So that's a good multiple star system, a good multiple optical alignment of stars to go out and see. While you're in this region, just 5 degrees over, so come down to Zeta and move over 5 degrees, is an open star cluster, NGC 6709. Pretty good open star cluster. Not a fantastic open star. There's a much sparser one between NGC 6709 and Zeta. So you can poke around this region, but it's a fairly star-rich region. So when you see an open star cluster, remember, open star clusters live in the plane of our galaxy, in the flattened disk of our galaxy. They typically contain a few stars, maybe 10 stars, up to a few thousand stars if they're really rich. My recollection is this one contains 70 or 80 stars. So it's about 70 or 80 stars, but if you've got a really rich region of stars, or the Milky Way, 70 or 80 stars on top of hundreds of stars is only going to be a slight enhancement of the stellar background. You might have a hard time seeing it. Further down here, about the same distance, about 5 degrees away from Delta, at the base of the kite, if this is the tail, 5 degrees away from Delta is a globular star cluster, NGC 6760. Definitely worth trying to see with your telescope if you've got your small telescope out, but it's a small globular cluster. It's distant, and it's only a couple arc minutes across, so you're going to see it as a little faint smudge on the sky there. Not going to be an extraordinarily dramatic object, but if you like a challenge, we've got some challenges here for you to see. Further down, if you're moving this direction, where theta and lambda sort of meet over here in the middle, below delta. If you think about taking the diamond of Aquila, that is this major part of Aquila, turning it over and making this a similar diamond down this direction. NGC 6814 is a spiral galaxy down that way. Hard object to see. You got a telescope, you want a challenge, go try to find 6814 and probe this region of Aquila. Now there's one more thing we want to talk about here. We talked about the variable stars last week. We got a multiple star system this week. Open star cluster, globular star cluster. Remember the globular star clusters, open star clusters, a few hundred stars, maybe a few tens of stars in the plane of our galaxy. Globular star clusters, a few 100,000 stars or more orbiting around the center of the galaxy, and that's pretty distant away from us typically. That's why this looks so small in the sky, despite being made of so many stars. I'm sorry, that's why this looks so small in the sky, despite being made of so many stars. So interesting objects, interesting examples of the two kinds of star clusters that we have. Spiral galaxy, thinking about, we live in a spiral galaxy, so we can think about these globular star clusters being around the center of such a galaxy. We can think about the open star clusters being in the plane of such a galaxy. So just good stuff to see. Hard stuff to see, but good stuff to see. The one other object we want to think about here is there are a few dark clouds in Aquila. And these are dark, cold gas and dust clouds that you just can't see through. And the sky's full of these things. If you look at pictures, go out and look at pictures on the web of various spiral galaxies. Spiral galaxies are different from elliptical galaxies. Elliptical galaxies have very little or no dust and gas in them, so that they look uniformly smooth and bright across there. But that's also why they don't do new star formation so much, because you need that cold gas and dust to collapse into new stars. Gravity's got to overcome the outward pressure to make new stars. That happens in the disks of spiral galaxies. And if you look at pictures of spiral galaxies out there, you see these dark knots and these dark twists. Those aren't regions where stars are missing. Those are regions of cold gas that blocks the light behind it. So there's a lot of stars behind there, but the light can't get through that cold molecular gas and dust and stuff that's in there, so you can't actually see through it, and it looks like a dark, starless region. Our Milky Way has that too, of course. We're a spiral galaxy, and the plane of our galaxy has that stuff. One of these things that's best known is called the Great Rift in Cygnus. If you live where you can see the Milky Way in your night sky, congratulations. Go out and look at the Milky Way, the hazy glow of the Milky Way stretching from Cygnus down towards Sagittarius. And as you get down past Albireo, as you get down past the middle of Cygnus right here, there's something called the Great Rift where this seems to go away, this glow of the Milky Way. And that's because there's a big molecular cloud. There's a big cloud of gas right there that's blocking light from us. There's pieces of that stretch on down here into Aquila, and one of the better ones of those is big, and it's right next to Gamma. So you start at Altair, and you move up to Gamma, and then you move on up again, and there's a big dark cloud right in this region. It's a hard thing to see. Try it with binoculars. I'm not sure it's going to look very impressive that way. If you've got a nice telescope, a good size telescope, a 6-inch, an 8-inch, a 10-inch telescope, but you have a telescope that's got a wide field of view so that you can see a wide expanse here, you might be able to start to really make out, oh, there is a very, very dark patch of sky here. There's a dark region where a lot of light is being blocked. just above Gamma. Go to Altair, go to Gamma, go the same distance up above Gamma right there, and start poking around this region of the sky. See if you can see some of that cold obscuring material that's really a bit of the Great Rift in Cygnus that stretches on down this direction. So that's what we got for you this week. Return to Aquila. We'll do something completely different. I'm not going to save this on my board for next week. We'll start all over next week and do something completely different, but I thought it was worth returning here since we only talked about variable stars and the bright stars here last time. So we got a few objects to go look for. Hope you have clear skies, everyone, and good observing. We'll talk to you next week. As always, thanks for watching.